All right, so I'm going to teach you how to multiply binomials two different ways, and then I'm going to show you basically the reverse, which is factoring trinomials, all in the same video because I think that makes kind of the most sense. All right, so first we're going to start with multiplying binomials. So you'll notice we have two binomials here. We know they're binomials because they have two terms. In our case, we're going to keep it with just the variable and basically a number. When we multiply binomials, I kind of want you to treat the things in parentheses as a single unit. We're going to take this single unit and multiply it to each of the terms in the other binomial. So that would look something like this. 3v, coming from here, multiplied to our little nugget, v plus 3, minus 4 times v plus 3. From here, I kind of want you to think of multiplying binomials as distribution twice. We need to make sure that everything on the outside gets to everything on the inside. So then we just multiply each part. So it's going to be 3v times v, that will become v squared, plus 3v times v, that will become 9v, minus 4 times v, and then minus 4 times 3, that will become negative 12. We are not quite done. One last step. We can combine our like terms here in the middle, giving us 3v squared, 9 minus 4 is 5, which is our answer. I'll do one more example with this particular method. 2m plus 3 times 6m plus 4. So we will take this nugget right here, this unit, and I want you to treat it as a single unit and multiply it in to each of the pieces on the other side, giving us 6m times 2m plus 3 plus 4 times 2m plus 3. From here, we just go ahead and do our distribution twice. Multiply in. 6 times 2 will be 12. M times m becomes m squared, plus 6m times 3. 6 times 3 is 18. And then the m comes along for the ride. Plus 4 times 2m, which is 8m. And then 4 times 3 becomes 12. We can combine our like terms, which will give us 12m squared plus 18 plus 8, that becomes 26m plus 12. Now, I'm going to show you a different method to do this. This first method that I taught you is the one that is preferred. However, this is one that you may encounter, especially by those who have taken math a long time ago, and I think I would be a bad math teacher if I didn't introduce it, even though I don't necessarily think it's the best way to solve these problems because it doesn't apply to anything other than this particular case. It's called the FOIL method. FOIL stands for first, outside, inside, last. It's basically just a way of making sure that everything gets multiplied together, just a way of remembering it. So let's go ahead and look at number 11. We're going to start doing our FOIL method. So first, we're going to do this one in blue. We multiply the first terms together. We multiply those two terms. 3n times 2m, that will become 6n squared. Then we multiply the outside terms. I'll do that one in red. So we look for the two terms on the outside. Multiply those together. 3n times 1, well, anything times 1, it becomes itself. So that will become 3n. Then we multiply the inside terms. I'll do that one in yellow. Those two terms, sorry.
The main office to sign your legislative envelopes. Lisa Tobler, Mr. Argyle, and Ms. Stewart. Thanks.
I'll go sign my legislative envelope in a minute. 7 times 2n, that will become 14n. And then we have to multiply the last terms, which is the second term in each binomial. I'll mark those in black. That will become 7 times 1, which is 7. Altogether, we'll end up with 6n squared, combine our like terms, plus 17n is 13, is 3 plus 14 is 17, plus 7. We'll do one more example with FOIL. I'll keep the same colors to make it consistent. Our first terms, I'm going to go ahead and just mark that above so it's a little easier to see. K times 4k, that will become 4k squared. Then we do the outside terms. I'm going to mark that below. K times 8, that will become 8k. Plus the inside terms. Oops. The two closest together, that will become 12k. And the last terms, that will become 24. Altogether, that's going to be 4k squared plus 20k plus 24. Now let's go ahead and basically do this process in reverse. Here is how we factor a trinomial. We know this is a trinomial because of the 3 terms. You'll notice that each trinomial has 3 different components. In descending power, starting with a squared and ending in a constant without a variable. Now basically what we're going to be doing is this process in reverse. We want to end with an answer where we have 2 different sets of parentheses with a binomial in each. To do this, we need to remember a very important key phrase. If x squared plus bx plus c, then we need the factors of c which sum up to b. Another way of saying this is you'll notice that we have a number here at the end. We need 2 numbers that multiply to that number but add to the middle number. That is what we are looking for. So then let's just think of every combination of numbers that we can that multiply to equal 24. I'll do that in green. 1 and 24, 1 times 24 is equal to 24. However, 1 plus 24 does not equal 10. So therefore, that is not what we are looking for. Let's try the next pair. 2 times 12 is equal to 24. However, 2 plus 12 does not equal 10. 3 times 8 is equal to 24. However, 3 plus 8 does not equal 10. 4 times 6 is equal to 24. And 4 plus 6 is equal to 10. So therefore, we can rewrite this as x squared plus 4x plus 6x plus 24. We could combine these terms to make 10, which is essentially, if you think about the last step that we did on the previous problem, we're just doing that in reverse. So now from here, we can rewrite our answer to fit this particular format. Well, we know what the variables have to be, x and x, because nothing else is going to multiply to equal x squared. So let's go x plus 4 and x plus 6. Let's prove this to ourselves. Let's show that if we did this technique that we did on the previous page, we would indeed end up with x squared plus 10x plus 24. I'm going to do it up here. So we have x plus 4 times x plus 6. Multiply the first two terms, we're going to get x squared. Multiply the outside terms, we're going to get 6x. Multiply the inside terms, we get 4x. Multiply the last terms, we get 24. Giving us x squared plus 10x plus 24. Meaning we have successfully factored our trinomial into two sets of binomials. Let's go ahead and do some of these other problems. Now we have v squared plus 8v plus 15. Let's just quickly list everything that we can think of that multiplies to 15. 1 times 15 is equal to 15. However, 1 plus 15 does not equal 8. 3 times 5 is equal to 15. And 3 plus 5 is equal to 8. So therefore, our answer is going to be v plus 3 and v plus 5. Some of you are going to be able to see this right away, and some of you are probably going to have to list out the factors. That's okay. Let's keep going. X squared plus 14x plus 40. Well, 1 times 40 is equal to 40, but that doesn't equal 14 when you add them. Same thing with 2 times 20, or 4 times 10. Oh, 4 times 10 is equal to 40. 4 plus 10 is equal to 14. So to break this apart, it's going to end up with x plus 4 times x plus 10. And our last one, we have r squared plus 14r plus 45. Let's go ahead and list out everything we can think of that multiplies to equal 45. So it's going to be 1 times 45, 3 times 15, and 9 times 5. Ooh, 9 times 5. 9 plus 5 is equal to 14, giving us our answer of r plus 5 times r plus 9. Now, the ones down here at the bottom are basically the same. This is Monday's lesson. The only difference is now we have some negative numbers in play. V squared plus 8v minus 20. So now we're going to look for numbers that multiply to equal negative 20, but add to positive 8. So let's think. 1 and 20 equal positive 20. We'd have to make one of these numbers negative. Negative 1 times 20 would be negative 20. However, they wouldn't add to 8. And same thing with the other way around. 1 plus negative 20 would not equal negative 20. Let's try 2 and 10. 2 times 10 is equal to 20. Negative 2 times 10 would equal negative 20. However, negative 2 plus 10 is equal to positive 8. Hey, that's what we're looking for. We have a factor of negative 20, two numbers that multiply to equal negative 20, but add to positive 8. So then our answer is going to be, in the same format as above, v. This time, though, it's going to be v minus 2 and v plus 10. Once again, I just want to make sure that we are convincing, so let's go ahead and multiply this one out the way that we did on the previous page. Multiply our first terms, we get v squared. Multiply our outside terms, we get positive 10v. Multiply the inside terms, we get minus 2v. Multiply the last terms, we get negative 20. Add those together, we're going to get v squared plus 8v minus 20, which is what we wanted. Let's go keep going. We'll just finish these out. We have 10. K squared minus 6k minus 7. Well, I can only think of one pair of numbers that multiplied equals 7. 1 times 7. Negative 1 times 7 would equal positive 6 if you added them together. But what would 1 plus negative 7 be? Well, that would be negative 6. So then let's go ahead and factor. We want it to be in the same format. So we'll have k's. And then one's going to be k plus 1 and k minus 7. Ooh, 36 is our next one. So we have 1 and 36. I think even if you put a negative sign on one of those, well, it would not add to equal positive 5 ever. Same thing with 2 and 18. 2 times 18 would equal 36. You stick a negative 2 there, that would be 16. You make the 18 negative, that would be negative 16. That's not going to work. We have 3 and 12. Multiply those together, you'd get negative 36. Negative 3 plus 12 would be negative 9. 3 times negative 12 would be negative 9, so that's not going to work. Let's try 4 and 9. I think we might be onto something here. 4 times 9 is 36. Negative 4 times 9, that would be positive 5, which is what we were looking for. We have found a factor of 36 that adds to positive 5. And you'll notice we have a negative sign there, so let's go ahead and write that. So that's going to be v minus 4 times v plus 9. Oh, I put the wrong variable, didn't I? Let's try that again. We have one last problem. We have negative 6. 1 times negative 6 would equal negative 6, but 1 plus negative 6 would give us negative 5. Let's go ahead and try negative 1 times positive 6. That would be negative 6. Add those together, we would get positive 5. So our answer is going to be b minus 1 times b plus 6. As always, let me know if you have additional questions.